G'day. Let's talk about something truly mind-bending, something that lurks in the deepest, darkest corners of our universe. Imagine a monster so powerful that nothing, not even light, can escape its clutches. This isn't a creature from a science fiction movie, mate. This is a black hole. It's one of the most mysterious and fascinating objects in the entire cosmos. For centuries, we've looked up at the stars and wondered about our place in the universe. But black holes take that wonder to a whole new level. They challenge everything we think we know about space, time, and reality itself. They are the universe's ultimate magic trick, a place where the rules of physics get twisted into a knot. So, what exactly are these cosmic beasts? In simple terms, a black hole is a region in spacetime where gravity is incredibly strong. It's so strong because a massive amount of matter has been squeezed into an impossibly tiny space. Think of it like squishing the entire mass of our sun down into a ball just a few kilometers across. The result is a gravitational pull so immense that it creates a one-way door in the universe. Once you cross its boundary, known as the event horizon, there's no turning back. Now, the idea of an object so massive that light couldn't escape isn't actually new. Way back in 1783, an English gent named John Michell first thought it up. He was a natural philosopher, a bit of a polymath, and he reasoned that if you could make an object dense enough, its escape velocity would be greater than the speed of light. It was a brilliant bit of thinking, well ahead of its time. He called them dark stars. But it wasn't until Albert Einstein came along with his general theory of relativity in 1915 that we got the real scientific framework to understand these things. So, if black holes are completely black and invisible, how on earth do we know they're out there? It's a fair question. We can't just point a telescope and take a happy snap of one. Finding them is more like cosmic detective work. Astronomers look for the clues they leave behind, the fingerprints of their immense gravity on their surroundings. One of the biggest clues is watching the behavior of stars. To understand how a black hole is born, we first need to understand the life of a star. Think of stars as giant cosmic power plants. They're massive balls of hot gas, mostly hydrogen, held together by their own immense gravity. Deep inside their core, the pressure and temperature are so extreme that something truly remarkable happens: nuclear fusion. The creation of an iron core is the beginning of the end for a massive star. It's a point of no return. You see, fusing all the elements up to iron releases energy, which provides that crucial outward pressure to fight gravity. But fusing iron atoms doesn't release energy, it actually consumes it. Suddenly, the nuclear furnace in the star's core sputters and dies. The outward push of energy that has supported the star for its entire life vanishes in an instant. When the leftover core of a supernova is more than about 3 times the mass of our sun, no known force in the universe can stop gravity's final, ultimate victory. The pressure from the neutrons isn't strong enough. The core continues to collapse, shrinking smaller and smaller and getting denser and denser. All that matter is being squeezed into an ever tinier volume of space. As the core collapses, the gravity on its surface gets stronger and stronger, so there you have it. The birth of a stellar mass black hole is a process of cosmic extremes. It begins with a star at least 20 times more massive than our sun living a short but brilliant life. It ends with the star's core running out of fuel, triggering a catastrophic gravitational collapse. This collapse leads to a supernova, one of the most powerful explosions in the universe. Right then, let's start with the most common type of black hole out there, the run-of-the-mill variety. These are the stellar mass black holes, and as the name suggests, they are born from the death of a single massive star. These are the ones we just spent all that time talking about, the dramatic final act in a supernova explosion. They are the small fry of the black hole world, but don't let that fool you. Now let's supersize things. If stellar mass black holes are the city-sized piranhas of the universe, then supermassive black holes are the great white sharks, the absolute apex predators. These are the undisputed kings of the cosmic jungle. We're not talking about a few times the mass of the sun here. We're talking about millions or even billions of times the mass of our sun. Alright, so we've got the stellar mass black holes on one end of the scale, weighing in at a few dozen solar masses. And we've got the supermassive behemoths on the other end, tipping the scales at millions or billions of solar masses. For a long time, it seemed like there was nothing in between. It was a massive gap in the family portrait. This led astronomers to wonder, where are the middleweights? Where are the intermediate mass black holes, or IMBHs? These would be black holes with masses ranging from about 100 to a few 100,000 times that of our Sun. Finding them has proven to be a cosmic game of hide-and-seek. Now we venture into the most speculative and perhaps the most fascinating category of all primordial black holes. Unlike their stellar and supermassive cousins, these black holes wouldn't have been formed from dying stars. Instead, as their name suggests, they would have been born in the very first moments of the universe's existence, just a fraction of a second after the Big Bang. In that incredibly hot, dense and chaotic environment, the pressure and density of the universe were not perfectly uniform. It's possible that some regions were so incredibly dense that they collapsed directly into black holes without ever having been a star at all. Right then, let's go on a bit of a cosmic safari and meet some of the most famous black holes that astronomers have put on the map. These aren't just theoretical concepts. They are real objects with names and addresses in the vast expanse of space. First on our list has to be Cygnus X1, the original poster child for black holes. Located about 7,300 light-years away, it was one of the very first objects to be widely accepted as a black hole back in the 1970s. It's a classic stellar mass black hole. So how do astronomers actually pull off the incredible feat of finding these invisible objects? It's a fantastic question. You can't just point a telescope at the sky and hope to see one. They are, by their very nature, the blackest things in the universe. Finding them requires a clever mix of observation, deduction, and some seriously advanced technology. It's cosmic detective work at its finest. It's easy to think of black holes as purely destructive forces, like cosmic vacuum cleaners that just devour everything in their path. But that's only a tiny part of their story. The truth is, black holes, especially the supermassive ones, are fundamentally important to the universe as we know it. They're not just passive residents of galaxies. They're actually active architects that help to build and shape the very galaxies they inhabit. The story of our modern understanding of black holes really begins with one man, Albert Einstein. Back in 1915, he published his general theory of relativity, and it completely revolutionized how we see the universe. Newton's idea of gravity as a simple force pulling objects together was basically thrown out the window. For a long time, the classical view of black holes was that they were the ultimate prisons. Once something crossed the event horizon, it was lost forever, and the black hole itself would last for eternity. But in 1974, Stephen Hawking came along and totally turned this idea on its head. He combined the principles of general relativity with the weird rules of quantum mechanics, and came up with a startling conclusion. Black holes are not completely black. While theorists were wrestling with the paradoxes of black holes, experimental physicists were chasing a different ghost from Einstein's past. His theory of general relativity didn't just predict that space-time could curve, it also predicted that it could ripple. He proposed that accelerating massive objects would create disturbances in the fabric of space-time, much like a boat creates a wake in the water. These ripples, called gravitational waves, would travel outwards at the speed of light, carrying with them information about the cataclysmic events that created them. Well, what a cosmic roller coaster that was. We've journeyed from the fiery hearts of giant stars to the silent, invisible voids they leave behind. We've seen how these stellar giants live fast and die young, ending their lives in a supernova explosion that is both breathtakingly beautiful and terrifyingly violent. Out of this celestial funeral pyre, a new kind of object is born, a black hole. For all that we have learned, it's fair to say that black holes remain one of the most profound mysteries in all of science. The more we learn, the more we realize how much we don't know. At the very top of the list of unanswered questions is the singularity. What actually happens at that central point where our laws of physics break down? Is it truly a point of infinite density? Or does a new theory, perhaps a theory of quantum gravity, take over at these extreme scales to describe a different state of matter? Unlocking the secret of the singularity isn't just about understanding black holes. It's about finding a new, more complete theory of the universe itself. Then there is the vexing information paradox. So our cosmic journey concludes where it began, with a sense of profound wonder. Black holes represent the universe at its most extreme and its most mysterious. They are a stark and beautiful reminder that we live in a cosmos that is far stranger, more complex, and more magnificent than we could ever have imagined. They are the point where the familiar rules of our everyday world are stretched, twisted, and ultimately broken. They are a tangible link to the beginning of time, the death of stars, and the very fabric of reality. They force us to ask the biggest questions about where we came from and what the ultimate fate of the universe might be. This enduring fascination is what drives science forward. The quest to understand black holes is a reflection of our own innate human desire to explore, to discover, and to make sense of the vast and beautiful universe we find ourselves in. The story of black holes is a story that is still being written. We stand on the cusp of a new era of discovery, with technologies that allow us to see and hear the universe in ways that were once the stuff of science fiction. The coming years promise even more incredible insights as we refine our gravitational wave detectors and point our most powerful telescopes at these enigmatic objects. We may one day solve the riddle of the singularity or witness the final moments of an evaporating primordial black hole. The universe is a big place, and it's full of surprises waiting to be found by those who are bold enough to look. So the next time you look up at the night sky at that beautiful tapestry of stars, remember what else is out there, lurking in the darkness between them. Remember the stellar ghosts, the galactic monsters, and the points of no return. These are not just objects of scientific curiosity. They are monuments to the awesome power and incomprehensible beauty of our universe. They are a constant reminder that there is always something more to learn, something new to discover, and something truly wonderful lurking just beyond the edge of our understanding. The abyss is deep, but it's a journey worth taking. Good on you for coming along. Fade to black.